So we're going to talk about logarithms today. We're going to explain what they are and how we can solve them. So logarithms are, or logs, are how we solve for exponents. Take a look at this expression. We have 10 to the third equals 1,000. Well, in that expression, we have a base, which is 10. We have an exponent, which is 3, and we have the answer of the expression 10 to the third, which is 1,000. So those are three components that make up this exponential expression. Well, in a logarithmic function, you're going to have the same three components. You're going to have a base, which is the 10. You're going to have an answer, which is 1,000, and you're going to have that exponent, which is 3. But what we do in a logarithm is we're actually solving for the exponent of the exponential function. So log base 10 of 1,000 is equal to 3. 3 is the exponent. So if we take 5 to the fourth power equals 625, we have a base of 5, an exponent of 4, and an answer of 625. If we want to know what the log base 5 of 625 is, it's 4, because 5 to the fourth power is 625. Likewise, if we take 8 to the second power equals 64, well then the log base 8 of 64 equals 2, because 8 squared equals 64. So again, what we're doing with logarithms is we're solving for the exponent of an exponential function if we did not know it. That's the reason we use logarithms. So how do we go about actually solving logarithms? Well, let's talk about the simplest ones first. And the simplest ones are base 10. Base 10 logs, because we have a log button on our calculator. Now it's located right here on the TI-84. You might have a different calculator, so you're going to have to look for it, but it should be pretty easy to find. And what we do with base 10 logs is we just type it in to the calculator. We could solve it. So when you get log base 10 of 100, what you're going to type is log 100 and hit enter, and you'll equal 2. Some calculators you'll have to hit on some calculators you'll have to hit the number first and type in 100, then hit log, then hit enter to get the answer. You have to learn how your calculator actually wants the inputs put in, but basically you have to type it in. So we can continue on here. You get log of 1600 is 3.2, log of 0.01 is -2, and log of 0.0785 is -1.11. So that's how we can solve very simple logarithmic functions. What about the other way around? Let's suppose we're given base 10 to a certain power, and we want to figure out what that number is. Well, in that case, what you're going to do is you're going to use the second function button and then hit the log button. And that will flip the function around so that it becomes 10 to the x power. Okay, so in 10 to the fourth, you'll hit second function, and then you'll hit the log button, and then you'll hit 4, and if you type that in, you'll get 10,000. 10 to the 5.78 is 603,000. Well, you're going to see 602,559.6, but rounded 603,000. And 10 to the -3 is 0.001, and 10 to the -4.67 is 0.000214. So that's how we do base 10 logs. Now let's talk a little bit about natural logs. And in natural logs, what we have is we have the same basic function, except for the same basic expression, except for our base is not 10, it's e, where e is 2.178. So if you have log e 7.389, that equals 2. Well, that's the same thing as saying e to the second power equals 7.389. Okay, you'll notice that the base is e, just like it was with the base 10 logs. The exponent is 2, just like it was in the base 10 logs. And the answer is, in this case, 7.389, just like it was in the base 10 logs. Okay, so the expressions are exactly the same. It's just a different base that we're using from the base 10 logs. So for natural logs, it's just we have a base of e. Now, what that means is that instead of writing log base e of some number x equals, we can just simply write the natural log ln of x, because we know what the base is. And what this enables us to do is, again, use our calculator, but now we're going to use the natural log button, the ln button on your calculator. Okay? And we're going to do the same sort of thing that we did before. So let's try a couple of these problems and see if we can solve these. So the natural log of 256, we're just going to type in ln 256, so you should get 5.545. The natural log of 0.067 is negative 2.703. So now let's do some inverse functions where we're going to take e, our base e, which again is 2.178, and it continues on, but 2.178, and we're going to raise it to a certain power. So what we're going to do is we're going to now use again the second function button and the natural log button. So we'll go to the second function button, and then we'll type on the natural log button, and we'll type in e to the 4.5, and we'll get 90.02. And e to the negative 5.7, we get 0.00674. Okay, so that should be fairly simple. Now, where it gets a little bit complex, especially for this class, is sometimes we're going to have to solve non-base 10 logs. Now, this is not something we're going to be able to do using our calculator. We're going to actually have to rearrange the function a little bit. So I'm going to teach you how to do that here. Okay, so we take the non-base 10 logs, like log to the fifth, log base 5 of 200. And what we're going to do is we're going to say log base 5 of 200 is equal to the log base 10 of 200 divided by log base 10 of 5. Okay, so that is how we can set up to solve this, because now we can use the log button on the calculator to solve the log base 10 of 200 and to solve the log base 10 of 5. So if we do that and we type those values into our calculator, in the numerator what we're going to get is 2.301. And in the denominator what we're going to get is 0.69897. So we now just evaluate that. We just divide those two numbers, and we get 3.2919. So the log base 5 of 200 is 3.919, or another way of saying that is 5 to the 3.2919 power would equal 200. Okay, so let's try one more of these. We get the log of 8 equals log base 8 of 567 equals, and we obviously this is what we're trying to solve. So what we're going to do is we're going to say log base 8 567 equals log base 10 of 567 divided by log base 10 of 8. Okay, so we set that up, and now we're going to evaluate the numerator and evaluate the denominator, and we get 2.754 in the numerator and 0.903 in the denominator. We solve that, and we get 3.05. So the log base 8 of 567 is 3.05, or another way of saying that is 8 to the 3.05 power would equal 567.